Hi, welcome to Cracking MBA. Today we're going to talk about geometric progressions. We will discuss about the basics of geometric progressions and also understand how geometric progressions is one of the three types of progressions, namely arithmetic progression, geometric progression, and harmonic progression. In this video, we will discuss only about geometric progressions. It is important to note that in CAT and other MBA exams, arithmetic progression and geometric progressions are the most important, and the majority of the questions come from these two types. Harmonic progression is not of that importance, but if you have a reasonable grip and understanding of arithmetic and geometric progressions, you're good to go. So arithmetic progressions and geometric progressions are important. So let's move on and see some quick definitions. So a series of numbers are said to be in geometric progression if they increase or decrease by a common ratio, say r. Okay, so if I have a real number called r and it is a common ratio between several terms of the series, then I can say that that particular series is in a geometric progression. So we can represent a geometric progression as a, comma, ar, comma, ar square, and so on. Okay. Now, if we see the series 2, comma 4, comma 8, comma 16, and so on, this is a simple geometric progression with a common ratio of 2. So why do we see that? Because we can see that if I divide 4 by 2, we get 2, 8 by 4, we get 2, and so on. So every successive term, if I divide by the previous term, we always get the same common ratio of 2. Okay, so that hence it is a geometric progression. Similarly, a geometric progression need not just have a ratio of 2, it can have 1 by 2 or any fraction or any real number like root 2 also. So if I see the series 4, comma 2, comma 1, so on, here we are seeing the ratio is r, ratio r is half. Okay, so hence if I multiply each successive term by half, the ratio we see, if we multiply each term of the series by half, we get the series as follows. Okay, so like we saw in the previous slides, a GP can be expressed as a, comma ar, comma ar square, comma ar cube, and so on up to infinity, where a is the first term and r is the common ratio. Okay, so if I want to determine the nth term of a GP, you can denote it as a into r power n minus 1. Okay, so let us see an example of a GP and see how we can identify the nth term and verify if it is actually correct. So we have a GP called 3, 9, 27, 81, so on, where the ratio is 3 and the first term is 3. Okay, so the nth term is nothing but a into r power n minus 1. So in this case, it is 3 into 3 power n minus 1. So if I want to get the fourth term of this GP, it is nothing but 3 into 3 power 4 minus 1, which is 81. And hence we can verify it is correct. Okay, 81 is the fourth term. So if I want to determine the 100th term, all you need to do is just multiply it by 3 into 3 power 99. Okay, so that is how you determine the nth term of a GP. Now let us see how to calculate the sum of n terms of a GP. Okay, so if I have the ratio is here, unlike AP, where we did not put a condition based on D, which is the difference, in GP, in geometric progression, the ratio has to be, okay, either greater than 1 or less than 1 or equal to 1. So if it is equal to 1, then it is just a simple series of all the same numbers. So if it is greater than 1, then we have a different formula for sum, and if it is less than 1, we have a different formula. Okay, so here if we see, if r is greater than 1, so for example r is equal to 4 is a number greater than 1, right, ratio is greater than 1, we get sum is equal to a into r power n minus 1 by r minus 1. If r is less than 1, for example r is equal to half, we get the sum as a into 1 minus r power n by 1 minus r. So it is basically the same formula, but just that you'll observe that the difference is the positioning of r power n and r has changed in both of them. That is because if r is less than 1, 1 minus r will be positive, right? If r is equal to half, half minus 1 will be negative, right? So to make it positive, we keep it as 1 minus r. So hence, if r is greater than 1, use the first formula. R is less than 1, use the second formula. Okay. Now let us see how we can apply it. So consider the same progression 3, 9, 27, so on. Here r is equal to 3 and r is greater than 1. So we get the sum is equal to a into r power n minus 1 divided by r minus 1. So if we substitute the value of a and r, we get the sum as 120. Okay. Similarly, find the sum if r is less than 1. And here we are not looking at just r is less than 1 and the sum of n number of terms. We are looking at the sum for infinite number of terms. Okay, so if I have a GP where I have infinite number of terms, then if I want to find the sum of them, you can calculate it as a divided by 1 minus r. Okay, so let us look at an example. Calculate the sum of a GP, which is as follows: 4 comma 2 comma 1 comma half 1 fourth 1 8 so on up to infinity. Here a is equal to 4, r is equal to half, so the sum is simply 4 by 1 minus r, which is 8. Okay, 4 divided by 1 minus half, which is 8. Next we can see how we can calculate the geometric mean. Geometric mean is nothing but the square root of both the numbers. Okay, the geometric mean of two numbers a and b is nothing but root ab. Similarly, the geometric mean of root of 4 comma 9 is nothing but root of 36, which is 6. Now let's solve some numericals based on whatever concepts we have learned. The fourth and sixth terms of a GP are 81 and 243 respectively. Find the 21st term if the first term is 3. Okay, so here the fourth term can be denoted as a into r power 3 and sixth term can be written as a into r power 5. So that's what we have the data given as 81 and 243 and we will mention as such. So dividing the second by the first, we will get r square is equal to 3 and hence r is equal to root 3. Okay, it is also given that a is equal to 3, the first term. So we want to calculate the 21st term, which is nothing but a into r power 20, which is nothing but 3 into root 3 power 20, which is nothing but 3 power 11. Okay, so this is how you can calculate any nth term. Now let us see another question. It is known that the population of a country was rising over the years and is as mentioned below. The first year of reference is 1995. What would be the population in the year 2006? Okay, so here we are given the terms as 100, 150, 225, 337.5 and so on. So here we can see that we have a series in which is in a GP and we have the first term and we have the ratio. We want to find the 12th term, which is 2006. Okay, so a is equal to 100, r is equal to 1.5 and the year 2006 is the 12th term of the GP. So we calculate it as 100 into 1.5 whole power 12, 1.5 power 12. Okay, that gives the population in 2006. Now let's look at an interesting question using GP. A boy drops a ball on the ground which rebounds 4 by 5, 4/5 of the original height. Find the total distance that the ball travels before coming to rest if it is thrown from a height of 120 meters. Okay, so this is a very good example of how GP can be used to solve real world problems. So the first distance that the ball travels is from the first height to the floor, which is 120 meters, and in each subsequent, so then it will rebound to 4/5 of 120 and then again it will fall back by 4/5 of 120. Okay, so that is basically the second journey is 4/5 of 120 plus 4/5 of 120. Similarly, the third journey will be 4/5 of again 4/5 of 120 and again 4/5 of 4/5 of 120 and so on. So this is nothing but a simple GP. Okay, we can see it is 120 plus 4/5 of 120 into 2 because it will rebound and it will continue like this. So what we need to do is here we'll clearly see that 120 is out of place. So what we do is to ensure consistency and form a proper GP, we add 120 and subtract 120 and we get a proper GP as follows: 240 plus 4/5 of 240 plus 4 by 5 square of 240 plus so on minus 120 because we are subtracting 120. Okay, so here this is the GP with a is equal to 240 and r is equal to 4 by 5 and we get the sum as 1200 minus 120 is equal to 1080. So next question is, here we have a square of side 100 centimeters. Another square is drawn by joining the midpoints of the sides of the previous square. The process is repeated infinitely. Okay, find the perimeter of all the squares so drawn. So here we have just drawn the two squares and you can continue this process up to infinity. Okay, so what we are seeing here is the perimeter of the first square is nothing but 4 into 100, which is 400. Okay, the perimeter of the second square is nothing but 4 into a by root 2. The third square will be 4 into a by root 2 into 1 by root 2 and so on. So this is nothing but a geometric progression like this: 4a plus 4a by root 2 plus 4a by 2 plus so on, where a is, the first term is 4a, which is 400 and the ratio is 1 by root 2. Okay, so if you are wondering how we got a by root 2, it is nothing but this side is the half of the square is a by 2 and this is a by 2 and the hypotenuse is a by root 2. Okay, The same process will continue, and each subsequent square, the side will be multiplied by 1 by root 2 of the original square. So this is how we calculate the sum to infinity. So this is how we are applying the concept of sum of infinity, sum to infinity of a GP. Okay, we will get the answer as 400 into 2 plus root 2. So this is it for all the questions in geometric progression. You can revise all the tips that we have, and you can also take the mock test on our mobile app, which has some of the real world CAD questions. If you have any questions, you can also reach out to us through our Android app. We have a forum there, and you can also ask your questions on the forum.